We have 3.3. This is the second part of 3.3. We worked on 3.3 on Thursday. We're finishing it up today. And the goal for today is that I can use the properties of equality. We talked about that at the beginning of class, that equality is so important in an equation because whatever I do to one side, I have to do to the other side, and it's still equal. So that is really important that we have that concept. I'm going to use the equality to solve coin and pouch equations, but also today, part B, we'll be getting into linear equations. Now the linear equations, you might be able to use the coin and pouches, but it might not make sense at times, so it could be difficult. Some of them, it makes perfect sense to use the coin and pouch approach, and on other problems, it doesn't make as much sense. Isaiah?
You want us to answer what does linear?
Yeah, well, we're going to do that as a class, and then I want you to write down the notes. So what does linear mean?
Has a constant rate.
Okay, has a constant rate. It's a straight line on a graph. Anybody else?
A straight line.
And then the last one I would say is that we have it's a relationship between variables. So if we have something that's linear, in our case, we're going to have this relationship between x and y. And as x increases, y will either decrease or increase depending on the kind of relationship. And we know that that relationship's based on this straight line and that we have a constant rate if it is linear. So if I move on to this next part, we have 20 coins over here, 4 coins here, and 4 pouches here. It says, explain how to solve this coin and pouch problem. How would I write this problem in y equals mxb form? How would I write this in y equals mxb form? Janai?
No.
What would the pouches become? How many pouches do I have? 4. And if you remember, we know that pouches are variables. So if I have 4, this becomes 4x.
Plus 4.
Okay, plus 4 equals 20. So in the sense of y equals mx plus b, what's 4?
Y. Coins.
It's your y-intercept. Okay? In this equation here, that's my y-intercept. Terry, what's this for? It is how many pouches, but in a y equals mx plus b form, it's a rate. This is a rate. It's a rate of 4. I don't know, 4 something. It does represent 4 pouches, but in this sense, it is a rate. What would be my first step here, Russ, to solve this equation? Do I want to take care of my pouches first or my coins first? Coins first. So, how many coins can I get rid of? I can get rid of 4. So I get rid of 4 coins over here. That becomes 0. And I get rid of 4 coins over here. And that becomes 16. So I have 4x equals 16. So then I divide both sides by 4. And I have x equals 4. What does that 4 represent, Casey?
That is your rate. No.
What does that 4 represent, Casey? How many coins are in a pouch, right? Excellent. So that 4 means I have 4 coins here, 4 coins there, 4 coins there, and 4 coins there. Okay? Maddie.
Doesn't the 4 in this equation, the x equals 4, doesn't it also mean where you are on the x-axis? On the x-axis?
Yeah. It means if I'm at 4 on the x-axis, I'm at 20 on the y-axis. Okay? So in this equation, 4 and 20 would be my 2 points. I would have 4 and 20. Okay, today we're finishing up on page 62 and 63. We have AL, BL, CO.